We had also taken this example of a race car. And suppose if you are driving the car at a particular speed, if you apply the brakes, the car will stop after a particular distance. Now my question is the speed related to the stopping distance when I apply the brakes? Is the stopping distance related to the speed? Yes, it is. Now, the first thing that we should do is collect data. Collect the data. Okay? All right. So speed and stopping distance, what does the data show you? Is it related or not related? When you see the data, probably your mind may not comprehend numbers, but your mind will comprehend visual representation. Okay? So what we try to do is, we will now see a fitted line plot. First of all, we can do a scatter plot and see, and then a fitted line plot. Fitted line plot is nothing but a line that is drawn on the scatter plot. Okay? And then this is very important. Which is the predictor and which is the response? That is very important because we are trying to see now what is the output that we are trying to measure? Stopping distance or the speed? Which is the output here and which is the predictor here? That is the input. So response, stopping distance is the output. So make sure that you put proper, I'm again repeating this because this is where I see people generally not conceptually clear on which is that the outcome and which is that is the predictor. So outcome is the stopping distance and the speed is the predictor in this case. And the y and x's are the name is given different for different analysis that we do. For regression, this is called response and predictors. Okay, it is called response and predictors. Okay, now let us go to MINITAB and try this speed and stopping distance. Super. So view data only. I'll go to speed versus stopping distance. First, as people said, we can generally do a graph and scatter plot also and do a simple scatter plot of this and see. That's absolutely not an issue. Stat, graph, scatter plot, simple scatter plot, okay. And what is the y output variable? Stopping distance. And what is the input variable? The speed. Now there is a driver reaction time also. I will teach you in the multiple regression, okay? So if you do this, how do you find this graph? Yeah, they are correlated. Can we see the correlation? What is the correlation? Correlation between stopping distance and speed. What is the value we are getting for the correlation? 0.994. So it is near to 1. It is positively correlated. Okay. How many of you are clear about this? So we have seen the correlation. Okay. Now we will do fitted line plot. This thing options, I'll remove the prediction for the time being. Okay, I'll put a simple fitted line plot. Okay, in the fitted line plot, I want to explain you. Now you have to pay close attention. Now, what are the things that you should see in this? First of all, do you see an equation? Look at the graph visually, okay? In the graph, first of all, you should notice that a scatter plot, we know that it is correlated. because 0.991. Then we know there is a nice line that is connecting. This line is called as a regression line. So that is the first, you notice the scatter plot. The second, you notice the correlation. Third, you notice the regression line. Next, you see the R square. R square is 98.9%. That means, do you see an equation here? The equation is stopping distance is equal to 109.8 plus 5.09 speed. Now, how is this equation helpful? This equation is helpful because if my speed is 70, okay, let me draw a line like this, okay? How is this helpful? If my speed is 70 or 60, I can sort of predict that it will be somewhere, stopping distance will be how much? How much will be the stopping distance? I just draw a line for you. Somewhere around 230. Now, that can also tell you, instead of just drawing a line and giving one value, it can tell you in what range that you can predict this. Okay, let me close this. And all of you, I'm going to tell you an important command, Control E in MINITAB. Control E will take you to the previous bars, okay? Then you go to options and display confidence interval and display prediction interval. And once you say okay, and then okay again, do you see some additions in this graph? Yeah, you see the additions, right? Now let me explain to you. Point number one that you noted was the scatter plot. Point number two that you wrote found was correlation, that we found it is 0.99, which it is correlated strongly. Point number three that we wrote was a regression line. Okay. Point number four we noted was the equation of the regression line. Point number four. Point number five is the R squared value, which means that 98.9% of the variation is explained by this equation. Okay. That means it's a good news. Generally, 90 plus is good. Okay. That is what is R square. So 5 points we have said so far. Now you see that you have a prediction interval. So suppose if I annotate and draw a line from 70 to this, and you will find that it is predicting within this band. And so you can predict something like this. Let me draw it for you. A line from here to here and a line from here to here. And this is the area values that you can predict. So MINITAB tells you, but then for any prediction, there is always a factor of risk, okay, that it can go wrong, and risk is 5%. So with 95% confidence, you can predict that if MINITAB gives with 95% confidence, you can predict something, right? Like in game and all, you bet, right? So which means that 95 out of 100 times you're right. Okay, great. Now let me go to the PowerPoint and explain a few things for you. Okay, whatever. So we have taken this pitted line plot, okay, and we got this details here, which we saw in MINITAB directly. So this is the line of best fit. This is called as the line of best fit. So we said that 98.8% of the variation that we see in the data is explained by the equation.